So from the weighted graph, suppose if you are having a if you consider this 10 points.
Hello, am I audible?
And graph also will become A, then I have to make this B, then it is your E. This is your,
Am I audible, students?
this is your B.
Hello?
So for each of these 4 edges of them, suppose if you take
Yes, ma'am.
it is A. But this graph will be undirected, no direction will be this there. Undirected, weighted. Why is the real value is represented on the page? It's a real image. If you do not have any word estimated to the age, it is known as the only undirected graph or undirected graph. And another, if you are having a real value associated with every edges, either directed or undirected, that is the case. But if you have any values,
So,
we can see we can age, we go there. So for that, we can
let's just draw one class diagram of hospital management system, okay? One class diagram of hospital management system. Students, pay attention, okay? We know that first we write name, then we write attributes, and afterwards we write operations, okay? So see here.
Okay, A to B, 0, A to B, 10. A to B, okay.
Patient.
Then 0, A to C, A, B to A, B to A, okay, again. Because it's undirected from A to B, you can do from B to A.
So, we know that patient will have a certain name, and name will be of what type of data type? It will be string type of data type.
B to B is 0, then C. C to B, C to A is 0, C to B is 0, C to B. C to B is basically C to C is 0.
Which will be kept as blank, okay?
And for D, only
because system will be keeping the name as blank because we are giving the user the privilege to enter the name. So that's why name, it is of string type and it will be kept as blank, okay? Next is patient. So these are private data types, name, then patient ID, because that's why I am providing minus. So see here, minus means private and plus means public, okay? Now see here.
Otherwise, all the zeros will be the same.
Patient ID.
So, for the directed graph as well, you could have a similar. So, this is the unrelated. Here also you could have 12. Yes. How? Very similarly, you have to
patient ID.
In this particular case, since it is a directed graph, so A to B entry,
which is of string data type.
A to B entry will be over. And to B to A will be because you cannot cross from B to A using this, because the direction of the A is from A to B. So A to B is one, but from B to A, it is
which should be assigned by the system because ID should be assigned by the system. It is not user generated, so that's why it will be assigned ASSI.
This is just the difference in the entry of the accessing matrix of the directed graph. So you have to follow the direction of the array, direction of the array, right? The entry
GNED found by system.
Okay. Next comes the axis is. So this is one of those. Now you can very well store this information.
Next is address.
You can create a two-dimensional array and store. You can get any of that.
which is of string data type.
Yeah, we see in the help of main case, you can use the adjacency. Now, in the adjacency, this situation, adjacency is what? It is basically the array of adjacencies. Why? Because for every matrix,
Which should always be kept blank because patient will be entering his own address. Okay. Next is advance deposit.
that we can draw. So you see, and the array of linked listings in the array elements consists of all the nodes, all the vertices of the input. So we call this as these adjacency lists array of. Okay. Now
Advance deposit, which will be in rupees.
This is unrelated. So see, for A, the guest list. A to B
Rupees.
otherwise we cannot go to anywhere. A to B. Okay. This is the list.
RUPP
All
rupees
the array of
equals to 0. Okay. Next is word number.
B, you can give either to A or you can give to C. B to A and then to C. This A to C, this means you cannot traverse.
Which is of integer data type.
This means A to A you can go as well as B to C you can. So a particular space, it is there in the very beginning of the list from that vertex where I can traverse, I will keep those vertices in the link.
And will be kept as 0.
So from this means.
Next is doctor, which will be of string data type. Okay.
You cannot traverse the vertex. A to C there is no. There is no A, but you can traverse B to C. So, but if you traverse that A, you do traverse this particular this from B to B, you can see
String 0.
that's it. Considering the first vertex B, what is the meaning that is
Sorry, doctor will be of string blank. Okay. Next is patient history. So patient history.
is well dedicated. B2B means that astronomy exists in an age from B. It's not necessarily that there has to be an age. It's not so. It means from the very first vertex that we see,
Patient history,
vertex
which is of string data type.
C, we can move to B as well as you can move to
Which will be kept as blank. Okay. Next is next operations. Okay. All these are the attributes of the library of the member of the name patient. Okay. These are the attributes. Now see here. Next is the operations. So next, let's just write the operations. What can be the operations? We can set the name of the patient. We can set the name of the doctor. We can get the advance in rupees. We can set the patient history and we can update the patient's history. Okay. So let's write down. Set name.
You have how many vertices in first line? So from A to B. Yes, from A to B. From B to C. From C to B.
Name.
And B
String.
so this is equals. I will A to B. From B, I cannot go to A. It is not possible from me because I am self direction of the arrow. So from B.
Next is set doctor name.
This is the B to C. A to C, B to C, C to B. I cannot go to B from C because the direction of the arrow is the opposite direction. C to B and B from B you cannot go to A. You can go to A, you cannot go to any other. From B to
Name is string.
okay. So from B you cannot go. This is the linked representation in the area of this is the axis. That's this to be of this particular. Then so for this particular graph.
Next, get advance. Okay. Get advance. So advance will be in rupees. So that's why rupees. Next is set patient history.
These products, that is breakfast search and breakfast search, that means you can have for a particular graph, you can have
Set
if you are having a
patient
breakfast search, whether it has to break this product, breakfast search product up to select and more you go to all other all other materials that
set patient history, and it is of string data type. Okay.
And from that is also unit. Once the exploration of that is completed, then you come back and one of the siblings of that explosion. Then you explore from that.
Patient history string.
This is the three system. There, each of these. So you are having each of these again, you are having this kind of system there in this case. Okay.
Okay. Next is update patient history.
And this is one, then 2, then 3. If I number this one, instead of 5, then 6, 7, 8, then 9.
Update patient.
From 1, if you are doing the breakfast, to breakfast. First, you select N arbitrary. That is what I first you have to select N. You can select this group number. So if you select group number, you will be having this select number 2.
Patient history string. Okay.
So if it's not the image, breakfast and the breakfast does not be moving easily. So we have now from 1, I am starting from 1. So from 1, I can go to 2, 3.
Patient history.
Okay, so from 1 to 2 to 3 to 4, because from 1 to 2, 3, 4. Now, from each of the 3 ones, what I can from
String, okay.
2,
So
I can consider
these are the different attributes and operations of the
from 1 we have already explored
class patient. Okay. So these are the different attributes and operations of the class patient. In this, it
if there is
name, patient ID, then address, advanced deposit, word number, doctors, patient history, all these are kept as private. And set name, set doctor name, get advanced, set patient history, update patient history, all these are kept as private data type. Okay, so is it clear to everyone?
Okay.
Is it clear?
I come back to 3. And from 3.
Clear everyone? Gautam?
I can explore it as well.
Gautam?
For exploring.
Shobhik?
8 to 9.
Shobhik Pal?
I can have A.
Pratik?
Okay. So 3, I can move to 8.
Pratik?
Come back to 1 and go to 4.
Shivdash?
4, we can go. Which are the nodes? The pain is
Konoy?
Yes, ma'am.
Konoy
Clear.
Raju? Shomita?
Yes, ma'am.
Neha Kumari?
As an example, there is also been given.
Neha Kumari?
Now, breakfast
Ritu?
So, break. So, to start from A, if I start from A,
Ritu?
if you are in a particular mode, the concept of breakfast
Mrinal? Mrinal Metari?
cannot go to the next node until we have explored all the adjacent.
Mrinal?
So, from A, first
Gudiya Kumari?
Okay, so A, B,
Gudiya Kumari?
okay, A, B,
Soni Kumari?
then C, over here,
Soni Kumari?
A, B, C, B, and C.
Samol Lai?
Yes, ma'am.
Clear?
From B, you can go to B.
Yes, ma'am.
You cannot go to
Oishi?
any other. And from C, you can go to
Oishi?
after you explore B.
Gargi?
C, so B is one. I can write down.
Gargi?
I can explore first C, then I can go to B. That would also be correct.
Manisha?
This is not. It will never be unique result.
Manisha?
Always certain multiple. So
Kuntol?
I can write E, then A, and then
Kuntol Kundu?
why I can write. So B, C, these are the
Mithilesh?
explore, and they are considered as the adjacent
Mithilesh?
of A. Now I can
Rohit?
explore C before exploring B because they are the same.
Nikita?
I can explore, but if I am exploring C,
Moitri?
objective is whatever.
So, this is a class diagram of this patient, okay, of the hospital management systems patient, okay. So now we will be learning about aggregation, okay, aggregation relationship. So this is another type of relationship which is representing the whole part relationship. So aggregation is a special type of association relationship where the involved classes are not only associated to each other, but a whole part relationship is existing between them. That is, the aggregate object not only knows the address of its parts and therefore invoke the methods of its parts, but also takes the responsibility of creating and destroying its parts. An example of aggregation is a book register is an aggregation of book objects. Books can be added to the register and delete as and when required. So aggregation is represented by an empty diamond. So see here. Not given. Yes, this one is aggregation. See, empty diamond. Okay, so aggregation is represented by an empty diamond at the aggregate end of a relationship. And an example of the aggregation relationship is this. Okay, see, item and order here. So so here each paragraph can in turn be considered as aggregation of lines. So here see the number 1 is annotated at the diamond end. Okay, A and star. See here there is a star is annotated at the other end. See this one and start. So this means that one document can have many paragraphs. So on the other hand, if we wanted to indicate that a document consists of exactly 10 paragraphs, then we should have written number 10 in place of star. Okay. So this is representing many. So if you are considering instead of many, you are considering 10 documents. So for that, you will be giving 10 in this place. Okay. So the aggregation relationship cannot be reflexive, that is recursive, that is in an object, that is an object cannot contain objects of the same class as itself. Also the aggregation relationship is not symmetric also. That is two classes A and B cannot contain instances of each other. However, the aggregation relationship can be transitive. So in this case, aggregation may consist of an arbitrary number of levels. So that's why it is a transitive aggregation relationship. So see here, this is an example of aggregation. Next comes see here. See, this is an aggregation relationship, that is document, paragraph, and line. So next is composition relationship. What is composition relationship? So composition is a stricter form of aggregation in which the parts are existence dependent on the whole. Okay, this means that the life of the parts cannot exist outside the world. In other words, the lifeline of the world and the part are identical. When the whole world is created, the parts are created, and when the whole world is destroyed, the parts are destroyed. So a typical example of composition is an order object where after placing the order number, so see here, this is order and this is item. Okay, so here this is an example of composition relationship in which an order object where after placing the order number item in the order cannot be changed. If any changes to any of the order items are required after the order has been placed, then the entire order has to be cancelled and a new order has to be placed with the changed items. Okay. As soon as an order object is created, all the order items in it are created. As soon as the order object is destroyed, all order items in it are also destroyed. So whenever we are creating an object, all the order items are also created, and if we are destroying it, at the same time it is getting destroyed. So that is the life of the component, that is order and items, is the same as the aggregate order. So here the composition relationship is represented with the filled diamond. So remember, in aggregate relationship we are also representing a diamond, but that one is kept blank, whereas here it is we are keeping it as filled diamond. Okay, at the composite end. So this is an example. Next is aggregation versus, so this is a aggregation. So next is aggregation versus inheritance, aggregation versus composition. Okay, so see here, we will learn aggregation versus composition and aggregation versus inheritance in the next class. So as of now, do you have any doubts, students? Any doubts?
It is very much equivalent to very much equal to the number of matrices. That is the age number of matrices is very much equivalent to.
Okay. So students, remember that you need, though two students are still left out in submitting the assignments. Okay. One is Sajjan Kumar and the other one is Vishwajit Prasad Singh. So these two students are left out and they need to submit the assignment by today. And if they do not submit it, then I will be putting 0 marks to them. Please inform them if they are in contact with you. Otherwise, I will not be giving marks, because this time if anyone is not submitting the assignment, I am not able to. I have strict orders not to provide marks to them. So I will be giving marks tomorrow. So by today, if they submit, then that's fine. Otherwise, I am going to put 0. Okay, students. So okay, we will again meet tomorrow. We are having class from, it's like we are having our class from okay, 1 to 2 lab. So in that lab, we will practice some more class diagrams. Okay. So, students, whatever I taught, just revise. And if you feel any difficulty, you can talk to me. Okay. So with this, I am closing the session. If anyone is having any queries, they can ask. And feel free to ask me. So, okay, students. So, any more queries? Okay. So, students, you can leave the session.
Would be, you can say it is order of E. E is the vector that will be dominating V, and those two terms of the